Good afternoon. The last time we looked at how to determine the ground state term for a p4 atomic orbital. Today, let's continue with how to determine the ground state term for a p5 atomic orbital. So first, we write down the angular orbital quantum number represented by L, which is 1. Then the magnetic quantum number represented by +1, 0, and -1, because the magnetic quantum number begins from +L, 0, and -L. Since the L is 1, we begin from +1 and ends with -1. Then the spin quantum number. Every electron can spin upwards, which we represent by +12, or can spin downwards, which we represent by -12. The next thing is to draw the orbital. The p orbital is a 3-degenerate orbital. Then we indicate the magnetic quantum number of each orbital. Then we fill with electrons. So we obey the rules in filling the orbitals with electrons. According to the Hans rule, we have to fill the orbitals with electrons. If the orbitals are degenerate, we fill with single electron in the same spin. Then if there are additional electrons remaining, we pair up in opposite spin. There is no electron remaining, so that is it. The next thing is to calculate the total orbital angular momentum represented by ml. The total orbital angular momentum is the sum of the magnetic quantum number of the orbitals that contain an electron. Considering the first orbital, it has 2 electrons. Since the magnetic quantum number is +1, taking into consideration the 2 electrons, it becomes 2. This is 0. Here we have only 1 electron. The magnetic quantum number is -1. So 2 minus 1, we have 1. Then we calculate the spin quantum number. The total spin angular momentum represented by capital M and S. So the total spin angular momentum can be determined by summing the spin quantum number of each electron in the orbital. This electron spins upwards, so the spin quantum number is +12. This spins downwards, so the spin quantum number is -12. +12 minus half is 0, so this will give us 0. This will also give us 0. So we can only consider this. It is spinning upwards, so the spin quantum number is +12. Then we calculate the spin multiplicity, which is 2s + 1, where the s represents the total spin angular momentum. So that is half +1. So we have 2. Therefore, since we have the total orbital angular momentum to be 1, our term is a p term, and the spin multiplicity is 2. So the ground state term for a p5 atomic orbital is 2p. Thank you very much.